Now we are going to take up that numerical which we missed in the previous slide. So it is a body initially at rest. So that means initial velocity is 0. It travels a distance of 100 meter. So that means S is 100 meter in 5 seconds. So this is the time, and with constant acceleration, and what we need to find that constant acceleration. So we will look for the question which will contain all those 4 variables. So it is S is equal to ut plus half at square. So putting the values, S is 100, u is 0, time is 5 plus half, a we need to find, time is 5, square of 5 is 25. So either you write this. So simplifying the question, anything multiplied by 0 is 0, half into a into 5, square of 5 is 25, or we can say that a is equal to 100 into 2 upon 25. So it comes out to be 5 5 25, 20, 5 1 5 4. So it comes out to be 8 meter per second square. So this is the first part. Now in the second part you need to find final velocity at the end of 5 seconds. So now we have the acceleration also. So here I will just put the value of acceleration, it is 8 meter per second square. So what you need to find? You need to find the final velocity. So we can use either of the equation, we can use the third equation also, we can use the first one also. So here I am making use of first because it makes the calculation very easy. So V is equal to U is 0, A is 8, time is 5. So V comes out to be 40 meter per second. So this is how you are going to solve for this question, right? So I think it's clear that how to solve for the the questions based on 3 equations of motion. So now we are going to start with another type of acceleration, that is acceleration due to gravity. You must have listened this word, that is acceleration due to gravity. Now what's that? See, gravity is a force with which earth attracts the object towards itself. Gravity is a force with which, I will write here, gravity is a force with which earth attract object towards itself. This is the gravity, right? So now we have one more term, that is freely falling body. What is freely falling body? Freely falling body is that which falls just under the influence of gravity. So I will write here, freely falling body is a body falling under the influence of gravity alone. That means there is no other force which is acting on that body, only the gravitational force is acting, that is why it is moving down. Suppose if I I have a marker in my hand, if I just throw it in this way, so that means I am giving it certain amount of velocity. So that means it is accelerating just due to the velocity which I am giving, as I am applying force on it. But if I just if I just release like this, so that means that that is the freely falling body, because on this body only the gravitational force is acting on it. Nothing is acting on it, because I haven't applied any force, I just threw it. So it was just falling under the influence of gravity. So it is said to be freely falling body. And all the freely falling bodies have the acceleration, and that acceleration is merely due to the gravity, and it is called as acceleration due to gravity. It is noted by small g. This acceleration due to gravity is different on different planets, or you can say it is different for different heavenly bodies. Like on earth, if we calculate, its value comes out to be 9.8 meter per second square, which you in case of numericals you can take 10 meter per second square. But if in question it is given that take g strictly as 9.8, then do not take 10, take 9.8 only. But the value of g is different at different places. So this is the value on earth. If we look for the moon, it is around 1.63 meter per second square. Right. So this is what is the acceleration due to gravity. And one more thing, the g is maximum at poles. Like on earth also we found 2 different values. It is maximum at poles, that is 9.8 meter per second square, and minimum at equator, which is just a difference of a unit, that is 9.7 meter per second square, right. And as you go into deep mines or as you go up to the height, G decreases, right. So this is what is the G. Now, if you if we are this thing using those three equations of motion, and in those equations if we involve the gravitational force or acceleration due to gravity, so those equations get modified slightly like this. Suppose we have first equation this, so it actually becomes, in case of acceleration due to gravity, it becomes V is equal to U plus GT. The only difference lies here that we are replacing A with G, because we know that acceleration is noted by A but acceleration due to gravity is noted by G. There is no difference in the unit or something, it is just the, you can say that acceleration which is merely due to the gravity, it is denoted by another symbol, that is the G, and it has different values or a fixed value at for different heavenly bodies. Likewise, the second equation, that is S is equal to UT plus half AT squared. It becomes like if we imply this acceleration due to gravity, so here S becomes H, because we will be throwing anything up or down. So we will take distance as height. H is equal to UT plus half GT square. So we have replaced S with H and A with G. And in the same way, we have third equation as V square is equal to U square plus 2AS. So like when we apply in the case of gravitational force, so it becomes V square is equal to U square plus 2GH. The difference lies only in case of A, it is replaced by G. So this is how you are going to, we'll put these equations and we'll see that these are actually Newton's equation of gravitation. Now one few more things you need to remember. See, anything which is thrown up, suppose I am standing here and I throw anything up. So at up, that means the like if I am throwing anything like this, so I will be imparting certain initial velocity, let's say x, but final velocity is ultimately going to be 0. And in the same way, if I am standing on the roof and I am throwing something down, then my initial velocity is going to be 0 and final will be something which I will be giving it. So you need to remember this. And moreover, when you are throwing anything against gravity, suppose I am throwing anything up, so against gravity, so there the G is taken as negative. But if I am throwing anything towards the gravity, that means from roof to down, so there the G will be taken as plus G. So you need to remember these things, because this will help you in solving the numericals. But if you will skip these things, so your question is just going to get crossed. So just practice these equations. I am just taking up the numerical problems now.